Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at Vieta's formulae. So these formulae concern the roots of polynomials. Now, the formulations look slightly different depending on the degree of the polynomial. We're looking here at cubics, so polynomials of this form, i.e. highest power of x is 3. So we're going to assume that the roots of this polynomial are r, s, and t. The fundamental theorem of algebra guarantees that there will be 3 roots here, but some of them might be complex and the roots may not necessarily be distinct. But it is sound that we can assume that there are 3 such roots. So they must satisfy each of these 3 equations. And you can see that they all refer to coefficients from the cubics. Okay, let's look at using this to construct a cubic with roots 3, -2, and 1. So in these formula, it really doesn't matter which you label R, S, or T. So I'll just label these R, S, and T. So when we're constructing the cubic, this first formula tells us that the sum of the roots is -b over a. So r plus s plus t in this case is 3 plus -2 plus 1. So the sum of the roots is 2. So -b over a is equal to 2. Now we're constructing a cubic. It doesn't really matter about the leading coefficient because we can scale that. So I'm going to let a equal 1. So that, of course, means that b would have to be -2. Now we can do similarly and find c and d from these formula here. So formula 2 tells us when we take pairwise products, so we take 2 of the roots at a time, multiply together, and then add these up. So this is rs plus rt plus rs. So adding up these, I get -6 plus 3 minus 2, which is -5. Because we chose that a was 1, this implies that c is -5. And for the last one, this tells us about the product of the 3 roots. Well, the product of these 3 roots, 3 times -2 times 1, is equal to -6. So -d over a, well, a is just 1, is -6. So that means d equals +6. So the cubic that has these roots is just a x cubed plus b x squared plus c times x plus d. This cubic here will have these 3 roots. All right, let's look at another question. So here we're given the cubic, we're told one of the roots is 7, and we will use this to find the other roots. So using these formula that were on the previous slide, let's assume that r equals 7. It really wouldn't matter whether 7 was r, s, or t. So what we have here is r plus s plus t. We don't know s and t. They're the other 2 roots. That must equal -b over a. Well, -b is +12. It's the negative of this coefficient. A is 1. So 7 plus s plus t must equal 12 from the first equation. Of course, we can write that a little simpler. It is s plus t is equal to 5. So from the third equation, this tells us the product is -d over a. So here d is 98 and a is 1. So the product of the roots, 7 times s times t, must be equal to -98 over 1. So that tells us that s times t is equal to -14. So we actually don't even need formula 2 here. We can use these 2 equations here to find s and t. So I'm going to rewrite this as t equals 5 minus s. Making t the subject means I can substitute it here. S times t is -14. So s times t equals negative 14. And we can easily solve this quadratic. We're going to expand. And remember, whenever we're solving a polynomial equation, including a quadratic, we need one side equal to 0. So add s squared to both sides and subtract 5s. So we're going to factorize these two numbers that multiply to negative 14 add to negative 5. I get s minus 7, s plus 2. So null factor law, s is equal to 7 or negative 2. Now, because it doesn't matter which way around we write the roots, either of these is fine for s. One of the roots we knew was 7. The other roots are 7 and negative 2. It doesn't matter in which order. So the roots of this polynomial are 7, 7, and negative 2. 7 here is said to be a double root. So that means if I were to factorize this, it would be x minus 7 squared times x plus 2. So I got this factorization simply from the roots. So here we've been able to factorize a cubic that we previously couldn't just by using Vieta's formula, and we didn't even need to use all of them. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.